All right, everyone, we'll go ahead and get started. So my name is Jessica Kreitzer, and on behalf of HyperQube and Analytica 42, would love to welcome you to our webinar series, Know Thy Enemy Through Testing and Validation. Today's episode is our first episode, Credential Dumping, Analysis, Detection, and Prevention. So today's webinar will be hosted by Craig Stevenson and Gabriel Martinez. Craig Stevenson is the founder and CEO of HyperQube, and prior to founding HyperQube, Craig was a PhD candidate in mathematics and worked at Raytheon in the cyber exploitation unit. Gabriel Martinez is the CEO and co-founder of Analytica 42, who partners with its clients to build continuous monitor programs to evaluate security risk and overcome big data challenges. Gabe has been in the security industry for more than 28 years as a consultant, instructor, engineer, thought leader, and investor. So now I'll run through some quick housekeeping items. All participants will be placed on mute. Questions can be submitted through the chat function. We'll be collecting and reviewing those questions and going over them in the Q&A. If we don't get to your question, we'll make sure to address it, and it will be sent out with an addendum, as an addendum in the deck that will be emailed to all attendees. The webinar is recorded and will be available next week during the HyperQube blog. So now I'm going to kick it over to Craig to get us started.
All right, am I unmuted?
Yep, we can hear you.
Excellent, excellent. All right, thanks everyone for attending. So almost all hacks follow a standard operating procedure. The first step of which is usually compromising a single computer on your network. Once they compromise that single computer, they try and spread like a virus from there to the rest of your network. That spreading is called lateral movement. So today, we're going to cover one of the techniques that SolarWinds used during the lateral movement phase of that attack. So we're going to go over how that technique works, how to detect it, and some steps to stop it. This is just one technique from one phase of the hacker standard operating procedure. The good folks at MITRE have been compiling the tools, tactics, techniques, and standard operating procedures of hacker groups into a framework they call ATT&CK. The MITRE ATT&CK framework organizes the different phases of a hack, as well as the tools, tactics, and techniques used during each phase. This information is actually compiled from real-world incidents that get submitted to MITRE. So from the while the ATT&CK framework lists all possible attack paths, this is an example of a single attack path. So attacker sends an email that compromises a single laptop. Once that single laptop is compromised, the hacker then collects all the credentials of all the users that have ever logged into that laptop. And from there, they're going to try and use lateral movement to pivot to all the other resources inside of your enterprise that the credentials on that computer give them access to. And with that, I'm going to turn it over to Gabe Martinez to talk about the solutions we're going to be looking at today.
Oh, great. Thanks, Craig. Can you hear me okay?
Yep, we can hear you great.
All right, excellent. All right, again, my name's Gabriel Martinez, CEO of Analytica 42. And what I'm going to demonstrate today is how leveraging the right tools and leveraging something like the MITRE ATT&CK framework can help you become a better analyst or help your organization better understand an attack and how it may or may not look like in your security stack, as well as how one might go about creating detections by analyzing the attack and coming up with detection mechanisms, and then ultimately prevent it, right? This is going to help reduce analyst fatigue and help improve your workflow. And, we say, know thy enemy through validation and testing. It's also know thyself as well at the same time. So we're going to talk about today's toolkit. So our friends at HyperQube, thank you, Craig, Jess, and Greg. This is let's go back. HyperQube is an incredible infrastructure environment that lets you build out cyber ranges where I can put in the host, vulnerable hosts, build out my security tool set, and then run tests in a controlled manner. I can do all this. If you know Visio and you can drag and drop, then that's all you need to know. You don't need to worry about ESX. You don't need to worry about VM servers or anything like that. And we'll show you what that looks like in a minute. In terms of what's inside the environment, we have mandiant security validation, which validates the effectiveness of your security controls against threats. So essentially, it has a big library of attacks that it can run and simulate against hosts, endpoints across your network in a controlled fashion. So we'll show you how to best leverage that. And again, it just makes it easy to have repeatable, scalable testing this way. You can also create your own tool sets, but we just found that this would be a great way to go. And then in terms of getting real-time visibility into what's going on in your environment, Analytica 42 chooses Devo as our log management and SIM of choice. So we'll be able to throw the logs that are going in the environment and do some analysis in there and come up with the detections. We'll walk through all that. Additional tools for what the scenario is going to bring is we're going to use Microsoft Defender as the antivirus of choice. So you may have other antiviruses as well. And if you're going to repeat and use this methodology in your environment, you would obviously use your antivirus for yours. But in this case, Microsoft Defender, it comes with Windows. It's decent. So we're going to leverage this from a detection and prevention mechanism. And then on top of it, for full visibility at the endpoint, we're going to leverage sysinternal sysmon. So this is an incredibly powerful tool. It's free, and it lets you get access to all the registry changes, all the processes that are being created on an endpoint, file rights, and things like that, and as well as network traffic. So that full rich environment, that logging mechanism is going to go into the Devo. So with that, let's go ahead and jump into the demo here. So I'm going to go ahead and share my screen. Okay, can you see my screen? All right.
Yep.
All right, perfect. Okay, cool. So again, just in terms of the demo, we're going to focus on Mimikatz, like Craig mentioned. So it's really an open source application that allows users to view and get access to credentials on the system. So it's going to exploit vulnerability in the Microsoft LSAS service, which manages sort of the single sign-on for a host. And all the users that log onto that system, this system ends up caching the credentials, and it has a mechanism of pulling out the NTLM hashes, the passwords, which then it can later on leverage and perform lateral movement against other systems. So for this environment, what we have here, so how we're going to do the analysis is we have HyperQubed, where we have an entire environment templated. We have 4 Windows hosts. So we're leveraging the mandiant security validation endpoint actors. And we have 3 Windows workstations, Windows 10, and then a server. And then we also have the mandiant director, which is going to control the attack to these systems. And we also have a network actor, which we're not actually going to use for this particular demo. On these same hosts, we also have sysmon configured in various configurations, and they are going to log all that information into the Devo relay, which is, if you're familiar with Splunk, it's like a Splunk heavy forwarder. So it's going to collect all those logs and send it to Devo Cloud, which we'll jump into and show you how to do some of that analysis. And again, what I love about the HyperQube environment is that if I all of a sudden need for my test, like a host, say CentOS, I could just pop on over, deploy a box. And again, I don't have to worry about ESX, but it's right now provisioning it and sending it up. So for my environment, I did exactly that with all the Windows hosts and configure it, and I can snapshot it. So it just really makes it easier to focus on that. All right, so now what we're going to do is go ahead and get into our environment. So this is the mandiant security validation. Some folks may know it formally as Veridin. And you'll see the various actors. We have the endpoint actors and we have the network actor. And in addition, we have a full rich library of attacks that we can use to simulate various scenarios. All right, so now I'm going to click on that. All right, and you'll see a whole bunch of actions that you can take. And in this case, I'm going to pull up for this demonstration the Mimikatz. And I did my latest update. And when I run this, and look at that. So, FireEye Mandiant has over 61 versions of it. You can also create your own. And so again, what I'm going to do is run this against those hosts and see what I can find. So again, I'm now going to kind of move into sort of this phase steps in terms of doing analysis. So first, we want to just get into collection and even know that we're getting the logs into our SIM of choice. So I'm going to go ahead and start with the Mimikatz variant. So this is compiled into some malware called Ace Hash. It's associated with APT41 and other actors like that. But the important thing here is that they're illustrating exactly what you should be looking for in terms of what's going on in your log. So we know it has a C64 executable. It's got some compiled data that it needs to decrypt. And then this -M is really please mimic Mimikatz or execute that bit of code to be able to hook into the LSAS. So I'm going to look for that just from the validation piece, and then we'll get a little bit more sophisticated in terms of how we're going to build some detections on that. So what I'm going to do here is now I'm going to go ahead and launch this, and I'm going to select the actors or host. But in this case, I'm going to just go ahead and go against the whole farm here. And I'm going to leverage the tagging system in the security validation, and any host that's associated with that tag, we're going to run against. All right. So now we can see it is preparing to do the attacks against each one of these systems. So while it's doing that, Craig mentioned about the MITRE ATT&CK. So the Mimikatz, just real quick, is considered credential dump and access. So while this is occurring, one of the key things that you should think about, and again, having this framework helps you put in context where you should look in terms of your logs or in order of events. So it's right smack in the middle of an attack chain. So what does that mean? Well, this tool tends to be interactive, and it means that the actor has a foothold into your network. That means somewhere along the line, there's probably logs or indicators that we can go hunt for to when that file was created or are dropped into your environment. So that may be a thing to look for. And then you can almost predict the future, because if they're also doing credential access, then most likely they're going to want to expand into lateral movement. So they're going to scan your systems, and that's kind of the discovery to figure out what other hosts they can achieve, and then use the username and passwords that were discovered during this credential dump and move laterally by using those username and passwords and trying to get a hold of other systems and escalate their privilege. So again, this is very powerful to always keep in mind when you're doing this kind of analysis. All right, so we can see that it's still running, and we have a couple of no. So in the Verident Mandiant world, when you see it was blocked, you might get a grade that says fail. What this means is that the attack successfully occurred, but it was not blocked. And then the inverse, if you have a host that has antivirus protection, then you'll see that it was blocked, and we'll see a grading system there. So let's jump into Devo and see what does this actually look like in my environment. So I'm going to click in here. If I go into Devo, so the first thing in terms of that collection piece, you want to see, am I even getting the Sysmon data set, right? So what I'm going to do is click here, and I'm going to go drop into Sysmon. And so again, Sysmon is incredibly powerful. It logs the Windows event system, and Devo has an endpoint agent that is able to pull those, and I was able to build, or Analytica 42 was able to build a full-on parser that takes a lot of rich information in terms of processes, original file, images that are running, and that kind of thing. So what I'm going to do is just kind of zero in. Again, this is kind of from the validation piece, just to make sure, am I getting the data that I'm expecting to, right? So I'm going to do this C64, .exe, and sure enough, if you remember what that clue was from the from Mandiant, you'll see that it is in fact running these type of commands, and it's also leveraging there. So I'm just going to go ahead and put exe. All right. And then what I'm going to do is, since it's not the full path, I'm just going to say essentially it contains. In this case, it's called a weak has. Hit that. And now you can see that it successfully ran on multiple hosts, right? So then We can see our HQ1 box got compromised, HQ3, as well as our server. Now we don't see HQ2. I mean, I happen to know that we have antivirus turned on, but you also saw it back here where it was blocked. So let's continue to do our analysis. And so the logging's good, the collection is good. So now what can we do and come up with ways of doing some detection? So if I'm coming in here, we see that the process was created, and you see some interesting things about this. So you might think, you know what, in my environment, I want to set a policy that does not allow executables to run in non-standard Windows directory. So what am I saying by that? You might have Windows C program files and then have any executable running there that's legit, or C Windows or C Windows System 32, but something running out of a user's public directory is probably not the best place for executables to go. So this might set off a type of investigation. Now this could be noisy in your environment, but at least we can start looking at that as a potential pattern. Now, you can get more sophisticated in this case where now if you're, like I said, you might, this case, Veridin mandate told us very specific here, but you know, I might have threat research buddies, or it might be in an ISAC that tells you a little bit more about what to look for in your environment. So in this case, you know, gleaning off Cyber War Dog, we want to actually get more specific and focus on when the executable actually connected to the LSAS process and pulled the credentials. So now with Sysmon, you're able to do that. So we configured Sysmon on one of the endpoints to be able to log the process and the process accesses. So we're just going to jump into that and see if we can get a little bit more sophisticated. All right, so I'm going to go do my search, and I'm going to go suspect process. So it's actually, you know, I've already defined the query, but in this case, it's event ID 10, which is process access, and you can see that right here, right? So that's being parsed out. And then particular is I want any successful accesses to the LSAS. So in this case, granted access after doing a little research and again, leveraging some of the blogs that are out there. There's a lot of documented you know, ways of looking at this. So 1010 equals it was successful access. And you can see the source image, which was C64 executable, as well as the call trace of the DLLs leveraged. So this is going to be a lot more specific and probably less noisy. So with Devo or with any SIM, you could take that combination and turn that into an alert, right? So you can go say, okay, I want this exact query and I want to, you know, make it severe, you know, severity of high or normal, create some categories, and then fire off alerts anytime you see this activity. And that's going to spawn off a whole other, you know, workflow. So with that, I mean, I also happen to know, let's see if it actually ran. Yep, great. So this is good. What I'm going to do is actually see the alert that we already created to give you an idea. So again, we leverage that logic to be able to see granted access to that LSAS process. And in this case, we snagged out the host name, with the offending executable, as well as, you know, the granted access. So this is a good way to start, you know, an IR process and kind of go from there. And what you might end up doing is saying, okay, I'm going to assume this was captured. What other hosts, what other users were on that system? Now let me look at any login activity from that system, from those users to other systems. So, but this alert alone can kick off that process, which is really what you want. Now that's kind of going forward, and I kind of mentioned, you know, well, maybe you want to look for how did you even get into the environment. So good thing, Sysmon again really does a great job of doing our tracing file access, file creates. So now I'm just going to look back in time where the target file happens to be C64, because I've already investigated that, and now I can see the target file was this. The process in Windows is a file create. All right, so that's good. And now let's go find the offending image. So here you go. It's Veridin backend. So you might say, okay, duh, because we ran the attack from it. But again, we're doing the validation in a controlled manner. So that way you can start building those detections and then test them out in your live environment. So this also could be, you know, a wget, or maybe it was a drive-by through a web browser that all of a sudden was the image or the process that wrote the file for the first time in the environment. So now, you know, this is good. You don't want to spend all your time hunting. You can roll this up and start saying, all right, well, I want to look for patterns that are direct access to LSAS. I want to look at patterns that are executables that are not. And you can roll those up into, you know, active boards, or you might, again, you may have other SIMs. But in this case, you can start, you know, having a board to which to launch potential suspicious activity. So we've created one here for all the Sysmon endpoint analysis. And let's see, pull that up. And of course, always doing a demo and always doing Zoom. All right, there we go. Okay, so now we create a dashboard that shows the suspicious executables, again, leveraging some of those hunts that we did with the queries. Executables that are running in non-standard ports. I mean, here's an example from, you know, just a standard Mimikatz execution, and you know, suspicious command lines that are coming from those. And then more in line with those alerts, suspicious processes being granted directly to LSAS and the hosts and when. So again, you want to be able to have this kind of visualization so that way you can start following up on it. You might notice here there's execution of Mimikatz. You might see the C64 attacker, but then you might see MSP engine. So you know, Microsoft is now, you know, hooking into LSAS, looking for behavior type technology hooks. So this is probably us catching that happening. And you know, this might be something where you want to filter that out, so that way you just focus on the exact events that occurred. So just keep that in mind. So now, so we talked about the collection. We got Sysmon, we got the data, it's flowing into your SIM. And now, so just a little bit about the prevention side of things. To prevent Mimikatz, again, it's well documented, but you can change the behavior of Windows itself, right? So you can enable LSA protection to allow untrusted processes from connecting to even preventing this happening. You could disable debug program privileges, again, required from this particular, you know, this particular attack. And you can disable password caching altogether. So why have the data store of the password sitting there for someone just to grab? So you could do that as well. And then probably I don't want to call it more mundane, but it is tried and true. Make sure you have the latest patches. Make sure you have a good AV. So, you know, Microsoft Defender is, you know, solid. You may have something like McAfee or Trend Micro, any of those are going to be good. And then, of course, make sure you have the latest signatures for that. You know, that goes a long way from the prevention. And then, or have a good EPP product, endpoint prevention system. So you might have a CrowdStrike or Carbon Black, or anything like that that looks for the behavior. So again, I would say the behavior of a process connecting to LSAS could, you know, is more of a behavior than an actual, you know, signature. So that's definitely something to be looking into. And then if I go back over here, now we said prevention, we have the AV. So what we also have done is built an active board around Microsoft Defender. So we've sucked in all the event logs related to that, parsed that out, and showing you Microsoft Defender board here. So in this case, we can see the executables that were blocked and the category, you know, in this case, it says a tool. And then if I scroll over here, then you can also see, you know, the virus type. So this you might be like, well, so what? You know, it stopped it. Well, that's great. Actually, you want to know that. So it's going to help validate to your, you know, your CISO, like, hey, look, our tools are working. This is how many blocks we stopped. So this is a way of showing value of the tool sets that you have. But another way of doing it is, again, since we're doing this in a controlled environment like HyperQube, you can introduce new AV tools or new technologies you want in your security stack to see, well, how will it performed in my various components of Windows and, in Linux or Mac in like in this case, the HyperQube environment. Will a different AV outperform, or will a different, endpoint protection give enough logging, or will an IDS system will look at it? So again, being able to see what deltas or changes in the deltas of your detection mechanism, that would go a long way. All right, so with that, I think what I will do, this is kind of a brief overview again from collection, from the analysis of the logs that would come from that collection, then coming up with creative ways for doing the detection piece, and of course then touching on the prevention mechanisms. So now let's go ahead and I'll stop sharing, and we'll get to the last slide and do some key takeaways. All right, great. So again, leveraging, so some of the key takeaways is, leveraging the attack framework first to understand how an attacker thinks, what the process is very important to make yourself a better analyst, make your organization finely tuned. So through that, you want to be able to leverage that and run the simulations and the attacks inside a nice controlled environment, such as a HyperQube, which does an excellent job. So you introduce your stack in there, and then you do the analysis against those. So it's beginning to understand and know thy enemy and how it's approaching. And again, your stack equals your, knowing yourself and how you would go about mitigating, detecting. Is there a gap? I'm not seeing anything. Do I need to introduce something else? Do I need to turn on logging? Like with Sysmon on one of the hosts, we did not have the process access turned on. So it probably didn't see that exact alert, but on a different system we did. So do we need to consider that? So it really helps separate the signal from the noise in the controlled environment. So once you hone in on that with the Mandiant security validation tool, then you push out all the detections and what you think was going to stop it. Then you go ahead and run that simulation in your live environment, and then you go beyond just the tech. Then you start testing the processes of your security organization, your SOC. You test the response, the playbooks, and so then you start testing beyond that. So again, but it all starts with that key understanding of how an attack occurs, and then how they're using the methodologies, being systematic about it. To be able to do that analysis. So cool. With that, I thank you for your time, and I'll turn this back over to Jessica. Thank you.
All right. Again, thanks everyone. We'll go to the Q&A in a second, but for more information, please follow HyperQube and Analytica 42 on LinkedIn and Twitter. You can also reach out to us via email. So now I'll kick it over to Greg for questions.
So we do have one question here in the chat, and Gabe, I'm going to direct this at you. So the question is, in your experience, what type of coverage is provided by the most widely used AV tools against this type of attack? Is this something that is still getting exploited on a large scale despite its age?
Yeah, it's being leveraged all the time. It is like the quintessential go-to capability. So not every environment's fully patched, not everyone's up to date. There's reasons why people can't update their Windows environments and affect it. So as long as that exposure is still there, then it's definitely a risk. And there's always variance in changing the methods. So I showed you sort of the basic one. They then get more sophisticated, and you might have to come up with different techniques. But it is definitely a key tool in the toolkit of the attackers. So.
Thank you. And we do have another question. Craig, this one is for you. What level of fidelity does the HyperQube environment provide?
Sure, I can help answer that. So the HyperQube environment is like your own personal private cloud. So as far as level of fidelity, anything you can do, pretty much anything you can do, you can replicate inside the HyperQube environment, meaning it will react and respond in the exact same way that your real infrastructure will. In fact, if you're using virtualization in your real infrastructure, if you're already using something like VMware, the HyperQube environment will respond exactly like your real infrastructure does.
Thank you, Craig. Are there any other questions by the attendees that we can answer for you today?
Well, so just to kind of sum things up, I actually have a question or two for Gabe. So this whole presentation started because we were talking about Mimikatz and specifically that attack. So let's just at a high level recover what we discovered. So when somebody goes to execute a Mimikatz attack, what is the thing that you're detecting?
So again, the various mechanisms, and probably in this particular scenario, the best part was taking executables or suspect executables that were hooking into the LSASS process and getting access granted, in which then, it means that they're getting access to, the credential dumps and store.
Gotcha. Okay. So in this particular case, it doesn't matter necessarily how they were trying to hook into the thing which gives them which lets them dump the credentials. What you're trying to detect is something hooking into the thing which dumps credentials, which shouldn't be.
Exactly. Yep.
All
and
right.
from there, you would want to see what users were on that system, and then maybe iterate those users. And this kind of goes in the IR and a little bit more in the lateral movement beyond this prezo, but you want to see where those users have been, maybe do analysis of user to hosts, and look at the patterns of where they've traditionally been. And if all of a sudden they're outside of the scope of hosts that they've seen, again, you can use something like a Devo to do that analysis and figure out, okay, oh wow, there's net new hosts that the user's never been to. Well, that's going to be suspect, right? So.
Gotcha. All right. Well, thanks everyone. If there's no more questions, we appreciate you attending our webinar.
Cool. Thank you very much.
Yeah, thanks again, everyone. And be on the lookout. This will be a series, so we will have more episodes of the webinar, and we hope that you'll all be able to attend. And we'll be sending out the presentation for you to review, and the recording will be available live next week on the HyperQube blog.